Hello everyone and welcome back to the Pong series. This originally was not supposed to be a series, it was supposed to be all in one go. However, it took longer than I anticipated. This was the first time I've made a boot sector game, and also making it basically just on the fly live. It took a little bit more time than anticipated. So it is in multiple parts, and I do plan on combining them once they're all done being filmed. But anyway, I guess since this is a channel on YouTube, and like they do on TV shows, we could say last time on the Pong series. And let's roll the clip. We have a paddle that can move on the screen, but there still are no bounds. So it can go beyond where it should. So we should address that next. So what we want to do then is actually in our down arrow logic here, we're going to bring in the paddle position, and let's do the up arrow branch first. That'll be easier, and then we'll have logic that makes sense. So we're going to compare AX to 0. Now there's other ways to do this that are probably more efficient, like we could use an OR. But just for clarity, we're not running out of bytes yet. We still have room. So we're not worried yet. All right, so we are going to compare that to 0, and if it is 0, jump equals, we're going to jump to our end get key because we don't want it to do anything. It's just going to ignore that key press. Well, that was easy enough. So now let's do this. If we're going to compare again, this time AX to, now remember there are 25 rows, so we're going to use number of rows, but that's to the bottom and we want the top. So we're going to subtract our paddle height. And if that equals, then we'll do our end. So 25 minus 5 is 20. The reason we did that is if we want to make our paddle 6, or if there's bonuses somehow in this game that your paddle can grow or shrink if you do things right or wrong. Anyway, yeah, so this is more variable this way. Anyway, 25 minus 5 is 20. So if the top of the paddle's at 20, don't allow it to go down any further. Let's make that once, and let's run that. So if we go all the way down, won't go down any further, and if we go all the way up, won't go up any further. Well, that appears to be working. So let's draw our CPU player's paddle. So now what we're going to need is, I guess this is going to be player paddle. And then we're going to do a CPU paddle. Well, I'd say we already have an issue here because we want to use this logic, all of this again, except with these variables being subbed out. So that's definitely sounding like a function to me. We want to use a function rather than, oh, well, wait, no, we don't want the down arrows and up arrows to change the CPU paddle, do we? So where do we actually draw the paddle? We do that up here. So this is not just a paddle loop, this is a draw paddle loop. And don't worry, we soon are going to be optimizing and cleaning all this up. So if you're yelling at your screen right now, I'm sorry, but we will get there. So we're just roughing everything out first, and then we'll clean it up. So we're going to create basically a function, and we'll call this draw paddle. Now this is going, let's say it expects for an input, we are working with DI is the location of the paddle on the screen. So DI needs to be set to paddle top, wherever that might be. So let's take all of this then and cut it out, and we'll call this draw paddle. Put this down here, and we have to add a return because it is being called, therefore we have to return. Now DI is the paddle top, and what we have here is we have paddle Y being set initially, and then we're multiplying it out based on where that should be located. So that's all good. I think what we want to do actually here is we want even this logic. So we might actually change this to AX is paddle top in characters, I guess. It's not in bytes, because DI, remember, has to be in bytes, so everything kind of gets multiplied by 2. So let's bring this down as well. All right. So this should still work. We haven't actually added any CPU stuff yet, but let's test it and make sure that we didn't break anything. Undefined symbol paddle Y. That's because we renamed it. We got that there, got that there, got that there, and that there. Make this again. There's still straggler. There we go. Okay, so that all still works. That's great. Now what we need to do is we need to somehow handle this though for CPU. So we're going to need like an offset. Now we're using BX here, we're using AX, we're using DI, and we're using CX. Why don't we use DX? DX is offset to start. So in the case of our normal player, our offset is 0. We don't have to do anything special for that. All right, now we're going to do the CPU version of the drawing of this. So we're going to do CPU paddle Y. And their offset's going to be a little bit different. So we need to go over 79 characters multiplied by 2, I believe. So let's try number of columns in a row minus 1 column, because it's 0 based. And then we're going to multiply that by bytes in a word. Now I think this should work, so let's see. Oh, that did not work. Let's hard code this to like the number 6. Okay, so this number might not be wrong. It's that we haven't incorporated DX yet. And that is true. We have not incorporated that yet. So let's see. What we need to do is after we multiply everything out, then that's when we want to start adding things. So let's add to AX, because we're using it to set here. So let's add to AX the dx value. There we go. So we have a CPU paddle and we have a user paddle. If we hit the down arrow, only one of them moves. Well, I think we're good with the CPU for now. It's obviously not doing anything, but we still have an issue. We're waiting for key presses. And the best way to illustrate that is let's add a ball. So the first step in adding a ball is we need ball X and ball Y. And ball Y. And actually, now that I think about it, as we move the ball on the screen, we need to know that DI location, the actual memory address. So let's make a function do that for us. Set DI. And what we'll have it do is we will have it take in as an input. We'll do bx equals y, and cx equals x. So we're going to have to change things around a little bit here. We're actually going to steal some of this logic here, take this out of here, and this is actually going to return under output. It'll output DI at the location in memory that we need to be. So let's see here. We will have to call it here. And it's actually going to take X and Y as characters. So we don't need to do any of this fancy byte multiplication. And we said bx was y, cx was x, bx, cx. Now we have to find a way to set ax here. So we're going to move into ax the number of bytes in a row. So what we need is the columns in a row times, well, it's already there, but that's the number of bytes we have in a row. And that is our ax value. After that, we will want to multiply it by bl. And what this will give us is we bring in our y value, multiply it by the number of columns in a row. That will figure out what row we're on. But we have to set the cx value yet. And remember, this is characters, not bytes. So we're going to have to take cx and actually multiply it by 2 first. So let's shift cx to the left by 1 place. Remember, in decimal, if you multiply by 10, you move the decimal place over by 1. In binary, if you multiply by 2, which is the base, it's base 2 instead of base 10, you move the decimal over by 1. So we have cx multiplied by 2, and we're going to put a note there, multiplied by 2, because cx is characters, not bytes. And then we will take ax and add cx to it. And I guess at this point, why don't we say we're setting our outputs, and we should be set. So when we come into drawing our paddle, ax will not be needed anymore, and what it'll be expecting is di to be the location in memory to draw the paddle. Let's see if this works. Oh, it still looks right. Okay, good. Now we can actually look at drawing that ball. So let's see here. Let's draw the ball after we draw the paddles, I guess. So what we're going to do is move into bx, that ball y value, and move into cx, ball x value. We're going to set di. And now, actually, let's see, what color do we want the ball? I guess a white space maybe? So we'll move into AX, white space, and then let's store string word. And let's see what that does. Oh, that did nothing. Okay, well that's always, oh, well it did. It's on top of the paddle, I bet. So let's put it somewhere out in space. There it is. There's our ball. Now, that ball's always going to be there because we're not actually telling it to move yet. But let's show that it's not going to move by itself, that it's waiting for us to get a key. So what we'll do is we will actually, were BX and CX destroyed in here? No, they weren't. They were left alone. Good. We don't have to set them again. So what we'll do is we'll just quite simply increment BX, increment CX, and then we will store those back to where they came from. So now, well, that's interesting. But anyway, we can see that the paddle has to move before the ball moves. That is not working at all the way it should. So let's actually look at maybe cleaning some of this stuff up a little bit. Let's try to make it more object-oriented looking, because right now this is kind of a mess. All of our constants for everything are all in one spot. There's really no clear indication of what this logic's doing because we didn't comment it, but that's because I planned on cleaning it up. And yeah, it's just messy. So let's clean it up a little bit, and maybe we'll learn something along the way. So let's add an include folder, and let's add a I guess a display. It's kind of going to be like a display class in a way. So this will be constants. And let's see, what else do we have in here? This is a display kind of thing because it's dealing with display memory. And then also like these things. These are like inline functions in a way. They're completely inline. So let's call these inline functions. And then let's add callable functions. All right, first things first, constants. Let's bring over the constants we care about. So the display address, let's change that to display.address. And put that there. Obviously, we need to include this. So let's include display.inc. Now, what else is display related? I'm actually not going to bring these global things over yet for the colored spaces. But the number of columns in a row, the number of rows, these are definitely display related. Up arrow, down arrow, that's completely different. Okay, so now for our inline function we were talking about, this is setting up the display so we can actually do stuff. So let's call it setup. So we're actually going to make a macro, and the reason for that is we don't want to directly insert this immediately. We want it to only insert when we want it to, if that makes sense, because we're not going to call it. It's going to be inline. So we'll do setup. It takes 0 parameters. And just occurred to me I haven't done my little normal marketing routine here for YouTube. So if you like this Boot Sector game content and you want to see more Boot Sector games, please do consider liking the video. That will let me know that you like this type of stuff. And if you like the stuff you see on the channel in general, please consider subscribing. It lets YouTube know that this stuff's worth watching so other people can find it. All right, well, with the marketing out of the way, now we have display setup. So let's do display.setup. And now for the black space, this was all clear screen stuff. So let's do that under the display here. Macro display.clearScreen takes 0 parameters. Oops, that I think needs to be all lowercase. And now this is looking for black space, so let's give it black space. This is going, let's make this like a local variable. Display.black space, and let's call these like local constants, and then we'll do another one here for I guess we'll just call it like logic. It's program logic. Or function logic? Sure. Why not? Why not? There we go. All right, so now it's going to take in our local black space here. And it will, well, I mean, it's not super local. Let's make it super local. Clear screen. There. Now it can't be confused. It's for this specific method, function, whatever you want to call it. Subroutine? All right, so we started at 0, which is fine. Columns in a row, this is now needs to start with display. And rows also needs to start now with display. We will call this display clear screen, and then we'll just call it loop, I guess. They keep our names very specific so that we will never run into duplicate symbol names. All right, so that worked out well. Let's call this now display clear screen. All right, so next we're drawing that separator. And I guess that is kind of a display thing, so let's do that there as well. And we'll do macro display.draw separator, 0 parameters. This takes blue space, which is very specific for this one as well. So we will bring that over now. The white space is a little bit more globally used, so I'm debating whether or not I want to define it each time, or if I want to just make that knowing that that is there. I guess I'll think about it. We got our local constant there, and let's include our function logic. And this is not clear screen, this is draw separator. And again, this is going to be display columns and row, bytes in a word, bytes in a word. Now, what does this equation mean? Well, rather than adding a comment, why don't we just create a variable and say what it means? So it means add 2 rows. Or no, This is adding half a row because we're dividing by 2. This one adds 2 rows. So we will call it half row bytes. Oh, that's sneaky. I was hoping it would give me the full autocomplete, but it didn't. And this one is going to be 2 row bytes. Or I guess technically it's 2 rows in bytes, but that's all right. Clear enough, hopefully, that people can understand what our code's doing now. And instead of this loop just being globally named, let's call it draw separator, and we can do that loop thing again. There we go. I think we should test to make sure that we didn't break anything. Is that spelled right? Separator. We'll leave it like that for now. Does not look right though. Does not look right. Anyway. Oh, look at that. Display black space. First use. All right, so it's not happy with that. And that's because we updated the naming slightly. After that, display bytes in a word. Oh, we left that global still, didn't we? Because that's kind of used well, we're using it specifically for display stuff though. So let's add that up here as well. Oh, it's looking better. Columns in a row. I suppose there's still logic here that that's not happy. So there's really no protection levels, so let's just kind of hard code that in here everywhere it's used. And then there's another one called rows. There it is. Okay, now will it build? Oh, bytes in word. Oh, there's a few of those. Yep, still, well, the ball's still broken, but the rest of it's still working. All right, so we actually kind of have cleaner looking logic here now. Let's see, what else is there? This DI thing clearly is a display thing. Let's take that out of there. This is actually a callable function. And we might do that as well. We'll call it bytes in a row. Display set DI bytes in row. And what we want to do with that is we want to equate that to this. there's really no other variables here. We still have to check out this logic and find out why it's, oh, we are changing CX. So this is being changed. That's why it's jumping across the screen so much. So, well, we're going to add more advanced logic anyway so that it's directionable, if that makes sense, where we can change the direction. So we're going to, we'll leave it broken for now, at least now I know why it's broken. Let's see here. So this is going to be paddle stuff, I would think. And then this is going to be, this is ball stuff. So this is going to be the draw the ball. So let's add a new include. Ball.include. Let's copy a lot of this stuff and then get rid of everything except for our headings. So we're going to need a ball X and ball Y. Now I realize there's only going to be one ball in this game, hopefully. So, but let's create a structure for that. And let me double check my notes so I don't look like a fool. Here we go, struct ball. And what we're going to do is we'll have an X value. We're going to reserve a word, exactly one word. We'll reserve a Y value as well, one word. And let's add a direction. We are going to need that eventually, and we'll reserve a word there as well. Just one. And our struct. Now, for direction, let's make this basically like an enum. Let's call it ball enum direction. And what we'll do is let's do going towards the top left, top right, bottom left, bottom right. And let's draw a little picture so that this makes more sense. The way this will work is 0, 0 bytes, or bits in this case, and then we'll put over here 1, and this will go this way, this will go that way, this will go this way, this will go that way. Betcha you didn't expect to see ASCII art today. Always here to please, always here to please. So what will happen is if it is all zeros, there's a lot more than just 2 bits in a binary or in a byte. So, but if the last 2 bits are zeros, the ball will go this way. If it's 1 in the least significant bit, it'll go that way. If there's 1 in, well, if this is the 0th bit in the first bit, it'll go that way, and then if it's 1, 1, it'll go that way. And what that does is you'll notice that when these are 0, the ball's going to the left. When these are 1, the ball's going to the right. When these are 0, the ball's going up, and when these are 1, the ball's going down. So let's declare that as well. We'll put in here ball. I guess it's sort of, I'm not feeling that. We'll do ball direction to the right. And that will equal And then instead of that, we'll do going. That way we can do going right and going down. Instead of to the down, that sounds wrong. And then this will be 1, 0. So now we can use this to test using an AND routine. So we'll show that shortly. And after a little comment here, we will put in here ball enum direction, because that's actually what it's going to hold. It's going to hold one of these values here. All right, well now we have to instantiate it though, and we have to call it something other than what it is currently. So let's do that next. To do that, let's call it game ball, because it's the ball in the game. I'm real creative, I know. And then what we'll do is at ball.x, define a word, and we'll just do the 10 that we had. And then at ball.y, we'll define a word, 10 also. And we can get rid of this. This is no longer needed. And then at ball.direction, we will do, let's do towards the top left. And we need to end our instantiation of a struct. So now we have a game ball. So our ball logic needs to change now. And the way that'll change is we'll use game ball, and we need to know the offset. So game ball has all of these, but we need to know how to get our x value, our y, and eventually our direction. So what we'll do is ball.x. Oops, sorry, this one was the y. That would created an interesting little bug, I'm sure, to figure out. This one was x. And I realize that our drawing logic is broken, but we will at least keep our logic the same. And I think we're at the point where we should test this again. Oh, we forgot to include our include file. Oh, it's not happy. Okay, this makes sense. Believe it or not, it makes sense. The reason it's not happy is when we go into our display logic here, we have this label. So this is actually the first stuff that it sees. And we don't want it to try to run this. Nothing is set up yet. So what we actually need to do is we need to jump directly into our game loop right away before we add any of this stuff. So let's jump to our game loop, and let's do a little bit of commenting up here as well. Now I don't remember if I already answered this, but is this the common way of writing assembly? Probably not. I think I mentioned this before. No one's probably really written x86 assembly since like the 1990s, so that's like 30 years ago. So at this point, it's probably the Wild West. We probably should be able to do anything that we want, and hopefully nobody will care. At this point, my way of looking at it is as long as you can read your own code, you're doing good. So I'm going to say that these are our classes, in quotes. And then after that, we will do our program logic down here. Now we still have constants, but I have a feeling that most of those will go away. So we won't worry about that yet. Oh, we need to set up the display. Let's create a new label. and offset everything to illustrate that we are tabbed over. And we need to jump to main. So let's see if this works now. Yes, it does. It's back to working condition. And our logic's a little bit cleaner. Now we can see we're setting up the display, we're drawing our separator, and we were working on adding this. This is our draw the game ball. So we'll find this macro, ball.draw, 0 parameters, end macro. That should still work. So now we need to include ball.draw where this used to be. This was our broken logic where the ball went flying across the screen. So we don't really want this anyway. We're going to do a different move ball logic. So we'll ignore that for now. And this is paddle logic. But what we're really doing is we're doing a get key, and I kind of want to keep that separate because if we incorporate any other keys, like if we use the letter R or something for reset, then that's not really a paddle logic. It's more of a key thing. So we'll call this keyboard. Keyboard.include. Don't forget to include it at the top. Keyboard include. And the only thing it really has right now is all this fancy paddle logic, but that's still logic, so take that out of there, bring it here. There are constants. There's the up arrow and the down arrow, as you recall. Keyboard. And there won't be a structure, but there is this inline function that we're concerned about. Keyboard get key. And our macro, and there are 0 parameters. These things are probably going to change soon too, but we do have to add the keyboard in front here. Where's the down arrow? Oh, there it is. Okay, so that's set now. This originally was right here. Okay. So let's see here. I feel like we should name some of these things so that later on when we're looking at it, we'll remember what we did and why. This didn't have any local constants, but it did have function logic. but we'll do this for uniformity reasons. All right, so what are you again? So if down arrow's pressed, this is paddle top from bottom, if that makes sense. We'll call it that for now. Keyboard get key paddle top from bottom screen. That's a really unusual type of variable name, but so be it. And all right, so we do have some branches in here. So let's call them things that we will know. Down arrow, get rid of the word branch, that's documented here. And this one was up arrow. And instead of just end, now it'll be keyboard.end, and we need to add that wherever it's being used. Here, 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 and here. And that should do it, at least for now. All right. So we have that done. All right, so I think the next thing we need to do now is let's make a paddle class, if you want to call it that, as well. So we will steal some of these little headers, get rid of this duplicate. Paddle height will be needed. And I also think that this white space officially should be in display as well. There we go. So we no longer have any constants up here, but we still have to draw our paddle. Now, we always have to set DI before we draw our paddle. That seems a little redundant, so let's just add that, and then instead of it requiring DI, now it requires BX to equal Y value and CX to equal the X value, since that's now part of the official call. And let's create a struct for this as well, so they're not just these free hanging paddle things. So we'll go under paddle here and let's add a structure. Actually, can probably steal a lot of this. And by a lot, I mean the X value, or rather the Y value. And now we need to instantiate that as well. So what we can do is copy this. This will be player paddle. We need just the Y value. This is paddle.y. This is paddle. And then we'll duplicate this and we'll call it CPU player. We can't just use CPU because that actually is a keyword in assembly. So there we go. We can get rid of this now. And we have to do like we did before. So we have player paddle plus paddle.y. It's a little overkill in this point because there is only one variable, so it's going to be that 0 address. But if we decide to add an x someday, like if we have bonus levels or something, it's good to have the logic already written. And we are enjoying our little headings here, so let's add another one and call this variables. All right, now we also have to do draw paddle, and this is a callable function. So let's do callable. White space is going to be display.whitespace now. Paddle height is now paddle.height. And let's name this thing and also bring over our fancy little colored explanations of what we're doing. So what we'll do is, this is columns and row, bytes and word, bytes and word. So this is going to add a row of bytes. So let's call it that. Paddle.draw paddle row and bytes equals this whole thing. All right, and that should be done as well now. Don't forget to include it at the top. And let's see, does it still work? Still works like it did before. Well, thank you for tuning in for the second installment in the Pong series. We look forward to seeing you in the third installment. And hopefully there's not too many more installments after that, but we'll keep working on filming and getting it to come together. So this was a large project, but I guess the bigger the project, the more things you run into, and hopefully it was educational for you, and hopefully you are enjoying it. I know I'm really looking forward to seeing the final product. So until then, we will see you next time and keep developing cool programs.